Let's explore the world of Internet Protocol headers. In this video, we will dive into the structure and functions of both Internet Protocol version 4 and Internet Protocol version 6 headers. We will understand how they work to make data transfer over the Internet possible. Get ready to unravel the complexities of Internet Protocol addressing. Here we have the Internet Protocol version 4 header structure. It's important to understand the format and fields of the Internet Protocol version 4 header. The Internet Protocol version 4 header is typically 20 to 60 bytes in length. Usually it is 20 bytes long when no options are included. It carries vital routing information. It also defines how packets are to be handled as they traverse the network, and it enables end-to-end delivery of data. Let's begin by understanding some of the key fields of the Internet Protocol version 4 header. The first field is the version field. It consists of 4 bits that indicate the Internet Protocol version being used, which is 4 for Internet Protocol version 4. Next, we have the Internet Header Length field. This field is also 4 bits long and indicates the number of 32-bit words in the header. Following that is the Type of Service field, which is 8 bits long. These bits are used for quality of service parameters, now referred to as differentiated services code point, and explicit congestion notification fields. Lastly, the total length field is 16 bits long and signifies the total length of the packet, including both the header and the data, in bytes. Let's continue discussing the remaining Internet Protocol version 4 header fields. The protocol field contains 8 bits, which identify the next level protocol being used. For example, Transmission Control Protocol is equal to 6, User Datagram Protocol is equal to 17, and Internet Control Message Protocol is equal to 1. The header checksum field comprises 16 bits used for error detection, but only in the header. It is recalculated at each hop. The source address field is 32 bits long and represents the Internet Protocol version 4 address of the sender. Similarly, the destination address field is 32 bits, but it indicates the recipient's Internet Protocol version 4 address. Lastly, the options field has a variable length, ranging from 0 to 40 bytes, and it is rarely used in modern networks. Now, let's shift our focus to the Internet Protocol version 6 header structure. The Internet Protocol version 6 header offers several key features. It has a fixed 40-byte header size, simplifying the header format. Unlike Internet Protocol version 4, it does not allow fragmentation at routers. It also omits the checksum, relying instead on the link layer for error detection. Options are handled through extension headers, and it uses 128-bit addresses, 4 times the size of Internet Protocol version 4 addresses. The Internet Protocol version 6 header includes a flow labeling capability as well. Let's explore the fields of the Internet Protocol version 6 header. The version field consists of 4 bits indicating the Internet Protocol version, which is 6 for Internet Protocol version 6. The traffic class field utilizes 8 bits for quality of service management, similar to the Internet Protocol version 4 type of service field. The flow label field uses 20 bits to identify packets of the same flow for quality of service handling. Lastly, the payload length field consists of 16 bits indicating the length of the payload, excluding the header. Now, let's compare Internet Protocol version 4 and Internet Protocol version 6. Internet Protocol version 4 uses a 32-bit address length, while Internet Protocol version 6 uses 128 bits. The header size in Internet Protocol version 4 is variable, ranging from 20 to 60 bytes, whereas in Internet Protocol version 6, it is fixed at 40 bytes. Internet Protocol version 4 includes a checksum field, which is removed in Internet Protocol version 6. Fragmentation in Internet Protocol version 4 can occur at both routers and the source, but in Internet Protocol version 6, it is source only. Lastly, options in Internet Protocol version 4 are included in the header, while in Internet Protocol version 6, they are handled through extension headers. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.